Hello, good afternoon. Can you hear me? Dao can you hear me?
Yes, we can hear you.
Uh, I have Dao I made you a co-host, so please have me admin uh, administrate more participant in.
Okay, can.
Let's give a few more minutes for waiting for more to join us. Now the number is still small. So meanwhile, if you have not done so, please join our department Telegram channel. I put it on the screen. All right, this is 105. Let's get started. Welcome to this online open house. We'll have a physical open house in the next Saturday. Today, I'm going to use this time slot to briefly explain to you why you should study physics and why you should study physics in NUS. I will leave some time for you to ask questions. And meanwhile, if you have any question, you can type into the chat channel. I will answer them at the end of the talk. Okay, let's get started. Well, I hope you have these questions throughout this talk. Uh, then this will help you better understand why I'm organized this talk in this way. So, why you wish to do a university study and how interested you are in physics. That will decide whether you take primary major in physics, second major, or minor in physics. And maybe a little bit, some of the misconception is what's the difference between physics, the physics you have learned in your secondary schools, and physics you're going to learn in university. And finally, maybe more parents are interested in should I worry about jobs? Well, I asked ChatGPT, GPT 5.2, why study physics in university? And ChatGPT gave me six reasons. And you can see the obvious reason should be deeper understanding of the universe, which actually, sorry, not six, five reasons, and is only the last one. The top one is learn to think rigorously. Physics train you to model the real system, making simplify assumptions and test your idea using experimental observation. Physics build highly marketable quantitative skills. These are useful in many areas of technology, not just physics, but also in AI, in finance, in engineering, and even in consulting. Physics also gave you access to a wide range of careers, which is in correspondence to the point number two. When you have many marketable skills, you can have wide range of careers. So it's definitely not true that if you take physics as your major, you're going to be a school teacher. That's not true. The majority of our students do not end up being a school teacher. Number four is the opportunity to do research and create new technology. I will come back to this point later. I will show you using some of the examples to show you some of the new technology actually developed by physicists. Well, first, physics actually is very useful. It's a useful subject. It's not just abstract and only study the universe. For example, physics of electromagnetic waves gave us our current electric wireless devices and all this telecommunication, etc. And physics of coherent lights is the background of laser devices. Physics of fiber optics, which is a Nobel Prize winning work, which gave us the current high-speed internet. Physics of fluid dynamics that gave us the aviation industry, how where the airplane works. And you may notice the airplane doesn't work as a bird. And so that's need a lot of physics to really make it work. Physics of semiconductor gave us computer chips and all the semiconductor devices. Physics of atoms and molecules is corresponding to quantum chemistry. And physics of solids, it gave us chance to innovate more our so-called super materials, which the material with the property does not exist in nature. We artificially create them. Physics starts actually with the big questions. Here, at least some of the big questions are waiting for you to solve, which have not been solved yet. For example, the fundamental understanding of quantum mechanics. We know quantum mechanics works very well, and we have many examples, including, but not limited to semiconductors. All the semiconductors based on quantum mechanical effect, and also the nanotechnology, etc. But how and why quantum mechanics work in the way it is we're observing is still not a fully understood question. We know how to compute, but we do not agree, not all physicists agree on the interpretation or the understanding. Another one is rather famous one is how to quantize gravity. Gravitational theory is by Einstein's general relativity works very well, but we all know it does not compatible with quantum mechanics. And so far, after hundreds plus years, we still don't know how to make these two reconcile with each other. Another deep question could be whether we need a better model for dark matter or dark energy. From the James Webb observation, it looks like our current model may not really work, and our explanation, understanding to the early universe may not be right because we found some of the rather large galaxies at the very early stage of the universe, which should not be there based on the current standard model on cosmology. There are many more similar questions that have not been answered. I'm waiting for you guys to do in your future career. Say why in this universe we have more matters than antimatters. The fundamental theory seems to be symmetric among the two, and with our daily life more closely with whether room temperature superconductor exist, whether we can find it, or if it does not exist, what's the deeper reason it cannot be exist? To solve our energy problem, whether we can have a nuclear fusion power plant, whether we can have it soon, or whether it's possible, or how to do it. All these are rather big questions. Meanwhile, in your generation, there are challenges. I list 4 challenges here. One is digitization, which is happened every day. Now, basically, all your life from your born is being digitized, and this also deeply uh, affect our life. So competition in semiconductor technologies is still rather crucial in the current economy. Nobel Prize in Physics has awarded the inventors of semiconductor in 1956. It's 70 years ago. Another one is the global warming and energy crisis. This is more and more visible. We can see more extreme temperature weathers, more frequent extreme temperature weathers, and also globally the average temperature is increasing more than 1.5 degrees before the industry area. And that would be leading to a disaster if we couldn't control it within 2 degrees Celsius. In 2021, half of the Nobel Prize in Physics is awarded to the modeling of Earth climate. Another possible challenge maybe happened soon is the quantum computing. If we can invent a general quantum computer, then will be a game changer for the next 20 years or more. It will potentially revamp the whole landscape of economy. 4 years ago, Nobel Prize in Physics was awarded to some pioneer work in quantum information. And last but not the least, artificial intelligence is already a great tool. Nobody can deny now in writing and coding, designing, and in research as well. Many of my colleagues using AI on a daily basis in their research. Some, like Elon Musk, predicts the artificial general intelligence is coming soon. Well, he predicts in 2 or 3 years. If so, and this will be a very big impact in everybody's life. The Nobel Prize in Physics in 2024 was awarded to the foundational work in AI. Talk about the Nobel Prize. I dig out a study on the academic background of Nobel Prize winners. This is based on the paper published on Social Sciences and Humanities Open in 2021. The data cutoff is 2018. So among these, I list the 3 science Nobel Prize in physics, chemistry, and medicine. And their degrees, bachelor degrees and PhD degrees, and percentage is there. So the diagonal would be physics degree holder eventually win a physics Nobel Prize, or chemistry holder win a chemistry, biology, or medical degree holder win a medicine Nobel Prize, and that's the PhD degree. So the diagonal, you may think the diagonal number should be 100%, which is not true. You can see bachelor actually didn't matter that much. It's about a little bit more than half is end up in their same discipline to win their Nobel Prize eventually. But the PhD matters a lot more. And almost all the physics winners have physics PhDs. And the same thing for the majority of medicine or biology. Nobel Prize winners have the medicine or biology degrees, which is understandable. But I want to pay more attention on this off-diagonal data. This 12% of chemistry Nobel Prize winners actually has a physics as a bachelor degree. And another 12, maybe the same 12, actually have a physics PhD. They eventually won the chemistry Nobel Prize. And it's smaller number, but it's also significant. 7% of medicine Nobel Prize winner has a bachelor degrees in physics, or 5% have physics PhD in physics. You should compare this data with their symmetric off-diagonal data. How many physics Nobel Prize winner has a biology degree? 1%. How many of them has biology or medicine doctorate degree? Nobody. And similarly for chemistry, the chemistry bachelor degree holder, when the physics Nobel Prize, the percentage is halved. And for the PhD is become less than 1/10 fold. So therefore, that means this saying two things. One is yes, majority. If you are really academic oriented, you wish your lifelong dream to be winning a Nobel Prize, then you should do whatever the discipline you are mostly interested. But also, if you study physics, it gives you better chance to win the prize in other discipline, not the other way around. If you study in biology, your chance of winning physics Nobel Prize is very, very low. I'm not sure if you know, the Nobel Prize in Medicine, 1962, was awarded. One of the winners is a physicist, Wilkinson. He's found the structure of DNA. His physics training started from phosphorus and electron traps, which is not much to do with DNA. Another physicist, Mansfield, won the Nobel Prize in Medicine in 2003 for magnetic resonance imaging, MRI. His physics training started from measuring Earth's magnetic field. He's still doing magnetic, but I'm pretty sure he has no idea studying Earth's magnetic field eventually won him a Nobel Prize in medicine. This is a very crucial, important technology in modern day medicine. All the modern large hospitals has MRI machines and very important machines to detect injuries. Okay, that's about the physics. Now let me talk a bit about NUS Physics, introducing the Department of Physics. Here's the profile of our faculty members, which we are the rather large a large family. We have 24 professors, 30 associate professors, including 6 on educator track, 15 assistant professors, and etc. And one important number is here, the undergrad and graduate students. So you can see we have 60 plus professors, and every year we admit about 60 to 70 students in the last 2 years. So that means if you come to our department has a fantastic good staff student ratio, which means if you come to our department, then you will be taken care of very carefully, and we'll pay a lot of attention to you because we do have many students, we have many professors. Here is a recent picture of the whole family, and from this picture you can see this department is very international. We have colleagues from Singapore, from Asian, from European, from American, from Australian, from all over the world. This is an international big family. This department is also value teaching very high. Here we listed some of the physics colleagues winning multiple university teaching award. If you come to our department, you have good chance to taking courses from these professors. You might be more interested in research. Loosely speaking, we can classify the research in 4 big areas, and plus 3 research centers which have a deep connection with the department. Before I jump into each area, let me emphasize all the professors in NUS Physics and pretty much every department in NUS are independent researcher. They do not work for another professor. So therefore, his or her group is an independent group, and they have freedom to choose whatever the research area. So these 4 groups is not 4 areas, not 4 big groups. Actually, we do not have such a group. It's rather I loosely classify my colleagues into these four areas. These four areas are strong area of this department. There are many other research areas may not have colleagues working in. We only have a finite number of colleagues. Okay. First one is nonlinear and complex system. Here is the research they're doing. They have non-Hermitian physics. They have non-equilibrium statistical mechanics. They have biophysics, including motor protein dynamics. For example, here showing one of the motors designed by one of my colleagues. You can see these are the molecules, and they behave like a motor in a car or in more mechanical machines. These are the colleagues working in this area. In the non-Hermitian physics quantum computing, we have Professor Li Qinghua and our department head, Professor Gong Jiangbin. In nanoscale transport, loosely, these four colleagues is working. And Professor Wang Zhisong is the one designing protein motor. Another area is soft matters and biophysics. We put some of the biophysics is one important area, and also in my personal belief is going to be booming in the future, which is using physics technology or physics method to study biology. There are many unknown unanswered questions in biology, and we physicists we have the skills to study those ones. And these are the colleagues working in this area. You can see I have listed Wang Zhisong in the earlier one as well. So many of our professors working in multiple research areas. They depend on their research interest and depend on also the trend or the opportunity they found some of the areas about to have a breakthrough. Another one may be interesting many of you is on theoretical physics and astrophysics. This including the high energy physics, string theory, and gravitational waves, black holes, etc. There are many fascinating area. And over here, I just randomly put in the random order and many colleagues working in this area. But they actually all these colleagues are working, as I said, independently. Sometimes we do have collaborations, but we have a rather different research interest and style. For example, Professor Taiming Chuan working in string theory. Professor Alvin Tra is in gravitational waves, and Professor Lo Hai Kwang is in quantum information and quantum technology. So you can see there are many different areas, but these are all theoretical physicists. Another and probably most popular or most important area is in condensed matter and material physics. This area is this is true throughout the globe. About most university physics department in most universities have the largest group being on condensed matter and material physics. These are the colleagues working on the next generation of semiconductor, how to improve it or how to use it, and in the optics, electronic, and different materials to have more advantage than the current semiconductor, all have a different design on materials which have superior properties than the current ones. And you can see we have a large number of colleagues working in this area, and these are just the list of some of them. And these are the four research areas. There are also three research centers are linked to closely related with the physics department. The one of the national research center is the Center for Quantum Technology, and most of you probably have heard of. And this, most of the I think more than 80% of the professors in the center are actually have joint appointment in physics. I have listed all of them here. They have that means if you come to physics department or choose physics as your major, then you may enter the class taught by these professors, or you may do research supervised by these professors. Another one is the Center for Ion Beam Applications, which is the research center within the physics department. All the colleagues are physicists. And nowadays, the ion beam is not mainly on the particle physics, rather the applications, how to use ion beam in material science or medical physics. This is rather important, and the nation, Singapore, also put a lot of attention and resource on studying how the ion beam treatment. For example, they have a proton treatment machine to treating cancers. And here at this center, we study how to use ion beam to apply on cancer or on other biological materials or semiconductor materials. On campus, there is another Singapore synchrotron light source, and the director of this light source is a physics professor. And this one is the X-rays, strong X-rays, again, mostly using for material science type of study, using this X-ray to change materials or study the property of various materials. So these are the research, and probably more important to you is in recent years, in the last 5 or 6 years or so, our physics department have a good we did a good job to recruiting the top talents from the world. And these are the recent recruit. And the first one, Ivan Gao, just recently got tenured and promoted to associate professor. All others are still president young professor in assistant professors. These are the top talent in their area, in their research area. To recruit president young professor, we need to compete to the entire university, and only very few being awarded every year. And our physics department are very lucky to be able to recruit two, on the average, about two such a young professors every year in the last 5 years. Okay, that's the research. And next, I quickly flash you the physics curriculum structure. And all this information are publicly available information on our physics department website. I just quickly flash you these ones. And if you have any question, I'm happy to answer them at the end of my talk. And you can also find this on our physics department, and no need to take note or read every line. It's too much information on this. First, most of you probably interested in primary major in physics. And these are the structure of primary major in physics. There are 9 compulsory courses all the physics major are going to take, and 6 electives among a very long list of, you can see there are 35 courses to choose from. These, you can choose these courses based on your interest, based on your strengths, and you may not know them now, but don't worry. After you clear these compulsory courses, all of you have no trouble to identify which electives you want to pick. And we have also academic mentorship to help you to decide, and if you're interested in certain directions, which courses you should take at what order. For physics major, you also need to complete a project or internship, which can be fulfilled by either some courses listed here, or final year project, which is not listed here, or taking an internship. These are the major. For primary majors, these are the we will have, and also secondary majors, we will assign you academic mentor upon your matriculation. Then you have you will have wonderful professors you can ask all these academic questions about throughout your first 2 years. For primary majors, we have also 3 specializations. These are the specializations if you are interested in specialize. Let me also emphasize for physics majors, you do not have to choose any specialization. And every year we have about more than half of the students don't specialize in any direction, which is totally fine. And physics training is very versatile. You don't have to specialize in particular direction. But in case you are really interested in one direction, say astrophysics, and these are the courses you may choose. All of these are part of the list, part of this long list over here. And so therefore, specialization means on top of these 15 courses, you can choose 5 from this list, and actually 2 of them can be double counted. That means you actually only need to choose 3 extra courses from here to fulfill the specialization. Similarly, on nanophysics, the list is even longer and including some of the courses offered in special program in science, not in physics department. And in the recent years, specialization in quantum technologies are very popular. And here are the list of the courses to fulfill for these specializations. So again, you don't have to specialize. If you do, that means 3 extra courses. So instead of 15, you need 18 to fulfill. If you are not that interested in physics, or if your friend already decided to do math or biology, and he or she may take up second major in physics, which can be completed in 10 courses. Among these 10, only these 3 are compulsory, and choosing 2 out of these 4 courses and 5 among these remaining you have not chosen, and also the 3,000 or 4,000 courses and their variants. So the second major can be fulfilled in much more flexible. All these are compulsory courses for first major, for primary major, but second major you can choose to read only 2 of them. If it's just a little bit interested in physics and don't have time to read 10 courses, and here is the minor. Only need 5 courses and don't need to read any 3,000 courses at all. You can also see we designed the minor as embedded in the second major, and the second major is embedded in primary major. That means you have freedom to upgrade. You may start with a minor, and along the way you found, oh, you really like physics, you want to read more courses. And upon your graduation, if we found you actually have 10 courses already, then we give you second major instead of a minor. And also, similarly, if you start off with a big ambition with the second major, but along the way you found you actually need more time or more your attention on your interests, then you couldn't complete the second major, but that's okay. If you complete 5 courses, and we'll award you a minor. So these are all flexible. There are also some other minors. Some of them are available for physics majors, some are not. For example, minor in biophysics can be taken up by physics majors as well, and also available for other majors. We have medical physics. Again, medical physics is also an important area, and Singapore actually desperately need the talents in this area, because all these big hospitals, they have many machines. For example, this MRI, which is the Nobel Prize I mentioned earlier, magnetic resonance imaging, and they need physicists to understand how this machine works. And this is not a doctor's job. Doctor is only for the human body when the machine gave them diagnose to how to treat it, but they need physicists to not operating, but understand how these things works. And this is needed for Singapore. Okay, that's also why we have this minor. And if you're interested in taking up this minor in the future, read a master degree, and then you'll be able to working in hospitals. Also, similarly, Singapore government also told us they need experts, local experts to understand climate science and climate change, and to understand how to predict, for example, predict your weather. Weather forecasting is also mostly physicists' job, and they need an expert to understand this. So we create this manner to train such experts for the local government and the local research institute. Nanoscience with a joint minor between physics and chemistry. And you can see the course is also half physics, half chemistry. It's an interdisciplinary minor. If your friend interested in this in astronomy, fascinating about stars, but don't have the chance to read a physics degree, then these are the minor for non-physicists, minor in astronomy. And these courses we designed for a non-technical manner to be accessible for non-physics major students can learn. They are study various aspects of the universe. And finally, let me use the last a few minutes to answer some of the most crucial questions may raised by parents. Can I find a job, or whether you can find a job after the university physics degree? I ask again GPT, what the key skills from university physics education you may learn? And this time, GPT lists 10 skills: analytic problem solving, mathematical reasoning, computational skills. Yes, in physics training, we train you a lot on computation as well. Data analysis and statistics, yes, we're handling lots of data and the real world data with uncertainty and errors. We understand how this error propagate, etc. And obviously, we will have experimental and lab skills training. And one of the strong skills for physicists is model building, and you can make justified assumption, connect theory to real system. And we definitely train you in critical thinking, and you will be trained in communication as well. Many of our courses have presentation or projects component in it, including the compulsory experimental courses. You need to present your result, communicate with the experts within the area or the public. You will have chance to have teamwork and project skills. And finally, physics training is very much adaptability. If you compare these skills to the top 10 skills listed by World Economic Forum in the last 15 years or so, you can see they are very high overlapping. So that means, based on this forum, and these are the skills the world need, the world economic need. And that means that when you have these skills, you should have job as well. And for physicists, your job is not just become a teacher in physics. You can have cutting edge researchers like professors or R&D sections in various companies. You can have study climate and environment, I have shown, in studying space, medical physics, and a large part of our graduates actually working in engineering. In education is included, energy is very crucial and also a big challenge facing your generation. Transport with rather large sectors in Singapore as well, and even music and TVs. Many of people that work in media industry need physics as well. You'd want to design animation or special effect which doesn't look real. And to understand that, you need physics and the data science as well. Maybe I want to emphasize, if a physics graduate can do an engineering job, why not reading an engineering degree? And the biggest difference is this. If you know what kind of engineering job you wish to do, for example, you want to be electronic engineering, or you want to be a mechanical engineering, then I recommend to take electronic engineering or mechanical engineering now. But if you're not sure yet, then you should take physics instead, because physics degree training can make you electronic engineering or mechanical engineering or biomedical engineering, etc., but not another way around. If you in the engineering department, your career is fixed. Mechanical engineering is hardly can working in biomedical engineering and vice versa. But physics can give you the access to those job career as well. And I'm pretty sure many of you are not that certain what you want to do in your life yet. And physics gave you that opportunity or gave you the choice in the future. And one thing, and this is pretty much the final point I want to make is the breakthrough of this round of AI started with the 2020 paper by OpenAI. This is a breakthrough paper, have 12 authors. I highlighted 4 of them, and these 4 have physics trainings. This 4 has physics or engineering physics as their bachelor degrees, and the first leading author is actually professors in physics department. And you can see physics training gave you vast versatile ability to taking on, for example, in this AI age. Okay, so since my time is running out, I will be very quick. Physics is a foundation for future and is impactful, intellectual, stimulating, and versatile. And Singapore need a lot of physicists. I will skip all this about student lives. If you come, you'll have good life and you will definitely not regret it. And the university education is really worthwhile. And these are actually the word I highlighting. That's actually what you actually looking for. It's not the knowledge, particularly in this AI world. And remember, each formula is not that crucial, but you need to empower yourself. And it's in this ever-changing world. And the mathematical and physical principles is important to advancing AI. Even you want to make a better AI, and then studying physics is a good choice instead of studying AI directly. One of my former students just last week we have an online meeting. He showed me what he has a new method to improve neural network commonly used using knowledge he learned in this department in physics. So the take-home message would be the future actually is uncertain. We do not know what area going to be definitely a leading job. Several years ago, computer science would be the top choice, but now you all know computer science may facing a big challenge, or data science big challenge to finding a job. So therefore, nobody is has this profit can see what happened in 4 or 6 years down the road, which area become booming. Therefore, you should keep your option open. And great value of physics training is certain, and physicists are impactful and versatile. That's all, and thank you very much. And I will happy to answer your questions. You may either unmute yourself or type into the chat channel. Thank you. In the chat, now I see there one question. This okay. A student's leaving. Okay, there are no question asked yet. Okay, any questions? Okay. I have a question. Do we have the opportunity to study overseas? Yes. Yes, we do. I think I saw the recent statistic is about 60% of science students have a chance to study overseas, either for one semester exchange or summer program or some immersion program. And yes, and physics also have extra opportunities because some of the universities have the special agreement with the physics department. Only physics students can access. Yes, you have good chance to go overseas. This is based on the applications, and we recommend to do it in the second semester of your third year. Okay. All right. Any other questions? Can we do two specializations like both? Well, in principle, possible, but in reality, no. Because first of all, it's not really necessary. Not even one specialization is not necessary. And secondly, the course can only be double counted, but not triple counted. So therefore, if you do two specializations, you need actual work, and you can see among these courses, there are also projects work in it as the choice. And most of the specialization, actually, the project is well, it's not compulsory, but almost all of them are doing it. For example, you don't want to take up the specialization without doing a project in that specialization. But for final year projects, you can only do one final year project. You cannot do two. So therefore, it's possible, but I don't think anybody has done it yet. It's not forbidden by the system, but it's definitely not a popular choice. And trust me, by the year three also, that time you would be definitely have your interest narrowed down. Normally will not be in two directions. Okay. Any other questions? Well, if not, I think my time is also up. And thank you very much. And if you can join our physical open house on Saturday, and you're welcome to visit our booth. We have many colleagues there to help you answer your more questions face to face. Okay, good luck to your applications and hope to see you all in the near future. Bye bye.